Okay, just want to look at some examples of how we can use these, what are called inverse properties of exponential and logarithmic functions. You know, the whole idea with logarithmic functions and exponential functions is that they are inverses, they're opposites. And when you compose inverse functions, meaning put one inside the other, they cancel. So, you know, these are the two properties. If I take natural log of e to a power, I get the power. Okay, this is asking me to put a number in for x, raise it to the power base e, and then take natural log of that. So I'm actually putting a number into the exponential function base e, and then putting that result into the natural log function. That's function composition. So this simple rule just tells me when I compose natural log with e to a power, I get the power. Okay, and the same thing works in reverse order. If I take natural log of a number, but raise that result to a power base e, I get the original number inside of logarithm. So, you know, an example, you know, for instance, this one, if I take e to the power natural log of let's say 2.8, I'm going to get 2.8. Okay, and then over here, if I take natural log of e to the power 11, I'll get 11. Okay, so when I combine log and exponential functions in this way, they cancel each other. Okay, so how can we use that? Well, we can use that idea to solve equations. Okay, in particular, equations that either have log functions or exponential functions in them. So if you look at this equation, it's an equation, 300 times e to the power negative 0.2t equals 700. Now, you know, in algebra, before you talk about exponential functions, you really have no way to solve this equation exactly, but now we do, because what I can do here, first of all, just a little organizational step here. I want to get the exponential function by itself, so I would divide both sides by 300, and when I do that, I would get e to the power, so I'm just rewriting the equation, e to the power negative 0.2t, okay, equals 700 over 300, which is 7/3. Okay, but the great thing here is that if that's true, I can take the natural log of both sides. Okay. Now, over here on the left, this is the great thing. Natural log of e to a power is just the power. Okay. Now, natural log of 7/3, well, that's a number. I don't know what it is, but I can find it on the calculator. So what we do know is that negative 0.2t is equal to natural log of 7/3, which means t is equal to natural log of 7/3 divided by negative 0.2. Right, I can just divide that coefficient of t over to the other side. And this is something you're going to have to find on the calculator. You know, as long as you're careful in how you type it in, it's really not a big issue. But if I go ahead and do that, it looks like I get about negative 4.236. Okay, and that's the answer. Actually, this is technically the exact answer, but we like to round it to a whole number, a couple digits past the decimal place, and see. And if you take that number and you put it back in for t in the original equation, you'll see that these two sides are equal. Well, actually, they'll be close to equal. If we round the answer, then it's not going to be quite the same thing. But 300 times e to the power negative 0.2 times this number, okay, negative 4.236. That'll be about 700. So we can check that it solves the equation. Okay. Now I can use the same kind of principle to solve an equation which has logarithms in it, except I use that other rule. Okay. So here I have 2 times natural log of 4x equals 7, and I want to solve this for x. Well, again, the first thing I might do is divide both sides by 2 just to get the log function by itself. Okay, when I do that, I have natural log of 4x, okay, equals 7/2. Okay, and all I did there is just some basic algebra. I divided a number on both sides of the equation. Okay, well, now we can use the rule which says that, if I can take both sides and raise them to a power base e, the left side is going to simplify quite a bit. Okay, so if these two things are equal, there's certainly no problem raising them both to the power base e, and they should be equal. Okay, but e to the power natural log of 4x is just 4x. Okay, if you look right back at our rule here, you know, that's what it says in general. E to a power natural log of a number is just that number. So if instead of x here I have 4x, that's what I'll get as an answer. Okay, so we do this to get rid of the natural log function. And on the right side of the equation I've got e to the power 7/2, which isn't a problem because that's just some number we can find on the calculator. Okay, so now I can solve for x. Just divide both sides by 4 here, and I'll get x is equal to e to the 7/2 power over 4, which again at this point you'd probably want to go to the calculator and get your answer. Okay, and the number I get is, let's see, it's about, let's say 8.279, so that's acceptable for the answer, about 8.279, which again you can always check these. Just go right back to the original equation that you started with, okay, which was right here with the 2 in place, and compute this expression on the left, replacing x with that number you found, and what you get out should be close to 7. And this one checks out as well.